Good morning, everybody. Today is Math 133, day 23. Um, we're going to look at the Chapter 10 project, but first we need to figure out our upcoming schedule. So I dropped a survey in the chat, or sorry, in Remind. I'll drop it in the chat here as well. Um, Unfortunately, I'm not going to be available to teach the evening Zoom session on Thursday, April 16th. So we were going to be covering the Chapter 11 project. So not this upcoming Thursday. This upcoming Thursday is normal. Okay, so today we're going to cover Chapter 10 project. Thursday we're going to cover the Chapter 10 review. Okay, so next week, Thursday, on April 16th. Um, so the evening Zoom session is not happening. So we need to figure out what to do with the morning session. So option one is I leave everything the same and we run the morning Zoom session, and the people who normally attend in the evening, they're just going to have to watch the recording. Okay, everything's still due. So the Chapter 11 project is due on April 21st. So that will still be the case. Okay, that's option one. Option two, um, we have some time. We could push everything a day later. So, in other words, we could cancel classes for both the morning and the evening for April 16th, and just push everything a day later. Right now, we're planning on spending 2 days covering the sample final exam. Okay. Um, if we push everything a day, then we'll have only one day to cover the sample final exam instead of two, which will be fine. Just for comparison, um, for the sample midterm, we didn't have any days set aside for that. The sample midterm, you'll remember that we worked on a little bit in this class, and then we worked on a little bit in this class, and then we worked a little bit on this class. And then Cindy and Elaine also covered a lot in their classes. So we actually have plenty of extra time to cover the sample final exam. And so if we miss a day, that won't be devastating. Okay. We will still have to do maybe a little bit here and there. Cindy and Elaine might still have to do a little bit, but anyway, so those are the two options. We can either uh, keep all the due dates the same and just cancel the evening class, or we could cancel both classes on the 21st and push everything, um, push all the due dates back a day. Um, so please go and submit your preference on which one you want to do. So do you want to hold? Should we do a should we do a class on the morning of Thursday, April 16th or not? Um, and so you guys are the people in the morning. So you guys' preference does definitely matter, since it's your class that we're talking about canceling. But I will be checking with the evening students as well. So and Elaine says that she and Cindy have 2 days set aside for the sample final exam themselves. So that's nice. So, uh, yeah. Anyway, so maybe I'll put my preference in. My preference in here since there we go. So I get a vote too, I guess. No, it's fine. Anyway, so please go and fill that out. It'll take you 2 seconds. All right. Um, so speaking of the sample final exam, we're not going to start on it yet, but we will be talking about it coming up soon. It's one of the best ways to study for the final. Um, so I'm going to be putting together some information about the final exam, so be on the lookout for that. The final exam is going to run very, very similarly to the midterm. Okay, so the midterm, you had two ways you could take it, and the same thing for the final. You can take the final exam in the testing center during the last week of class. So that would be Tuesday, Thursday. Tuesday, Wednesday, Thursday, or Friday that week. So April 28, 29, 30, and May 1st. Friday is May 1st. Okay. So you can take it any of those days at the testing center, or you can take it with me on Zoom on Thursday, April 30th. Okay. The final exam is going to be uh, I believe it's 12 pages instead of 9 pages, so it is slightly longer than the midterm was. But if you remember with the midterm, a lot of people, you got done with it and you still had time. We had on Zoom, we were there for 3 hours. The same thing is going to be true on April 30th. If you take it with me on Zoom, we're going to be starting at 9 a.m. In the morning. We'll also be starting at 6 p.m. in the evening, and we'll do 3 hours for that final exam test. So if you did run out of time or you were very close to running out of time on the midterm, you might consider taking the final exam at the testing center where there's unlimited time. Okay. As long as they are open, you can take it there. So because it is slightly longer. When I say slightly longer, so if the exam took you, so we're going from 9 pages to 12 pages. So if the exam took you 2 hours last time for the midterm, then now you're looking at 2.5 hours. It's not a huge jump. Okay. Um, okay. So be on the lookout for more information about the final exam coming soon. I think that's all my announcements. Let's jump into our project for today, which is the Chapter 10 project. Chapter 10 project is on page 574 in your course pack. Page 574. And we're talking about candy again. So in addition to page 574, you're also going to want to make sure that you go and get your numbers from when we counted out our candy. Okay. So I told you to make sure you save those in a place that you can get to them, right? Because we're going to be using these numbers for the chapter 9, 10, and chapter 11 projects. So we already did the chapter 9 one. Now we're doing chapter 10. Okay. So I don't want you to have to go and buy another bag of candy because you're like, shoot, I forgot where I put my numbers. Um, all right. So, in addition to your candy numbers, you're also going to need to click on the link to the random levels of significance. Okay. So we're going to come over here to StatCrunch. Okay, so in Canvas, if you click on the Chapter 10 project, there is a link for random levels of significance here. If you click on that, that will open up this StatCrunch link. Make sure you sign in, and I'll drop this one in the chat for you, okay? So you don't have to go search for it. So there's that. So you'll need that link as well. Okay. All right. So let's go back to our project. Okay. Um, use the StatCrunch file, MAT133 random levels of significance to generate two different random levels of significance. To do that, we'll do data, sample, choose a levels of significance column, and a sample size of 2, and then hit compute. So I just need two random numbers. And these level of significance is your alpha, okay? You'll remember that alpha um, is a small number. It's related to your error. Okay. So it's specifically what the probability of making a type 1 error is, okay? So we don't want to make errors, right? We want to be correct. So because of that, you want your alpha to be small, okay? But you can't necessarily just make it as small as you want, okay? Um, choosing the correct alpha is an important part of hypothesis testing. It's the first part of hypothesis testing, and it's important to have a discussion with whoever you are doing these analyses for, whoever you're presenting your final results to. You need to have that discussion about what alpha we should pick. Okay, you can't just pick a random number. Okay, now a normal alpha is like 5%, right? We've talked about 95% confidence intervals. 95% is something that's very common to see. And that's because, under 5% we said is unusual. So an alpha of 5% would be an unusual event. Okay. So, but sometimes we need to have an alpha that's a little better, like 1% or less. Sometimes you actually want an alpha that's larger, maybe 10%. Okay. I wouldn't go above 10%, but like 8, 9, 10%. Um, why would you do that? Alpha is your error. Well, it's the probability of making a type 1 error. Probability of making a type 2 error is related to your alpha. And if you make your alpha too small, then you have a higher chance of making a type 2 error, which could also be a problem. Okay. So you have to discuss which is worse, a type 1 or a type 2 error. Now we are talking about candy. So if we make an error, type 1, type 2, nobody's gonna be mad. Okay. Nobody's dying over this. But if we were trying to see like how effective our vaccine was, okay, a type 1 error might mean that you inject someone you inject someone with this vaccine and it causes side effects. That could be a problem. A type 2 error, you might, inject someone with this vaccine, or you might not give someone this vaccine when they actually need it and they end up dying from it. So that is a problem. Okay. So, uh, yeah, anyway, let's go back to talking about M&Ms and less gruesome topics. So, uh, for our case, we're not going to have that important discussion about picking a good alpha. We're just going to pick two random numbers. Okay. Um, but I just want to point out that that's not normally what you do. Okay. All right. Anyway, let's go to our levels of significance over here. Da, 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 da. Okay, so I dropped this link in the chat already for you. And you can see that these levels of significance, they go from like 10.1%, 9.9 down to 1.1%. So somewhere between 1% and 10%. Okay. Um, and the confidence levels that we talked about, remember that if you take your confidence level plus your alpha, that equals 100%. So the confidence, if I do a level of significance of 10%, that means I'm doing a 90% confident. I'm going to be 90% confident in my results. 1% alpha means my confidence level would be 99%. Okay. All right. Anyway, you want your confidence to be high, you want your alpha to be small. All right, we are going to click on data sample, data sample, click on level of significance, and choose a sample size of 2. And then you hit compute, and it's just going to pick 2 of these numbers for you at random, and then you're just going to write those on your paper. All right, so 0.093 is what I got, and 0.071 for the other one. Okay. You're going to get different numbers, and I want you to get different numbers. Okay. But that's what I got. So again, I did data, sample, clicked on level of significance, sample size of 2, compute. Okay. I'm going to use these ones here. Okay. And you'll write those right here. Okay. So I'm going to be using this one for M&Ms, and I'm going to be using this one for Skittles. Okay. That's all. That's all it means. So we're going to start with M&Ms. And for M&Ms, we are going to be uh, doing this first level of significance. So mine is 9.3%. Yours is different, which is totally fine. Okay. And which M&M color had the highest count in your sample? If there's a tie, just pick one of the ones. Fill out this table for that color. All right. 3 decimal places for p hat. Uh, if your p hat is close to 1/6, 1/6, there's 6 colors. 1/6 as a decimal is 0.1667. Choose the color with the second highest and redo the table. Um, so why is it saying that? So um, we are trying to test whether the M&Ms that we uh, have the same count, which they'd all be at 1/6, or if the proportion is different. Okay. And in order for something to be different, it has to be significantly different. It can't just be slightly bigger. So if I had my p hat is 0.168, that is very close to 0.167. And so I'm not going to actually be able to tell if there's a significant difference. There might be a significant difference. It's just that my test is going to fail because I'm going to fail to reject the null because I'm not going to be anywhere close to the level of significance that I need. Okay. So the idea with a hypothesis test is you are testing some claim, some hypothesis, and you're testing it at the certain significance level. And if your result shows that your sample is so far out to the left or so far out to the right that there's no way that this came from random sampling, then you can be confident that something interesting is happening. And that's when we reject the null and we accept the alternative hypothesis. Now, we can never we can never accept the null hypothesis, which is saying that no, this sample is the same as the population. Okay. We can never do that um, because just because it's a random sample. Okay. But anyway, so that's why we need to avoid this situation. So anyway, let's take a look at what we have. So M&M with the highest count, let's go find it. My highest count was orange, and I had 28 oranges out of a total of 140 M&Ms. So write out what you had. What was your highest count? How many? And you'll remember that that p hat is x over n, right? So I need to put this in the calculator. 28 divided by 140. Mine is 0.2 on the nose. That never happens. Um, give 3 decimal places for p hat, so I guess I'll put 0.200. But if yours is some other decimal like 0.215, that's fine. Okay. Um, I just got lucky this 0.2 on the nose. I think that happened last semester too. Okay. Willy Wonka is bothering you again. So why is it always Willy Wonka? Like I thought Willy Wonka was like he was a he was a bad guy, right? Who was the bad like chocolate guys? Was it like Prodnose and Fickelgruber, I think. Those were the bad guys in the bad chocolatiers in Wonka. Anyway, Willy Wonka's back. He's bothering you. Claims that more than 1/6 of M&Ms are your color from number two. So he's claiming that more than 1/6 are of all M&Ms are orange. Okay. Write the appropriate hypothesis test to test Willy's claim. Use a fraction, not a decimal. Okay. So our null hypothesis is that P equals 1/6. Um, your null hypothesis is always going to be around P, okay? Because P is the population proportion. And we don't know the population proportion. We can't know it unless we counted every single M&M in the world, right? Instead, we did a sample and we got P hat, and we say that P hat is close to P. Well, what is P? I don't know. Your null hypothesis saying that P is 1/6 for orange. Okay. Now, your null hypothesis is always going to be equal. P equals something. Here we're going to use a fraction. Sometimes you'll use a decimal. We'll use a fraction in this case just because we have 6 colors. Okay. Your alternative hypothesis, which you can write as H1, or that kind of implies that there's an H2. There's not. You can write it as HA instead for the alternative. Either way is fine. H1, HA, I don't care. Your alternative hypothesis is that P, and then you'll do either greater, less than, or not equal, depending on whether you're doing a left tail test, a right tail test, or a two tail test. Now, left and right are just greater than or less than. Here, he's saying more than, so that is telling me that it's greater. Okay. There is a difference, though, between a two tail test and a one tail test. We'll see that when we get to Skittles. So it is important to pay attention to that. Okay. Here, more than, so we're doing greater. Okay. So everyone's going to have the same numbers here, or sorry, same hypotheses here. Okay. You're going to have different, you might have a different color that was your highest, you'll have different levels of significance, but everybody's hypotheses are the same. All right. Page 575. Verify whether the conditions are met for verify the requirements to conduct an appropriate test of hypotheses have been met. So make sure that we have satisfied the central limit theorem. Okay. So we need to make sure that it is random. Make sure that it's independent. Make sure it is normal. Our sample, right? So, all right. First of all, random. Uh, we didn't pick and choose our M&Ms, did we? Right? We just got a random bag, right? So yes, every M&M, every candy had equal chance of ending up in our sample, right? Every candy had equal chance of being in the sample. Okay. Independent, we need to check 20n is less than n. So 20 times, I had 140 M&Ms, which is 2800. And that is less than all M&Ms. This eraser is trash. Oh my goodness. Sorry, everybody. Shouldn't even tried. Uh, Is 2,800 less than the number of M&Ms? Yeah, definitely, right? For sure. Yes, of course. For normal, I need to check that NPQ is bigger than 10. Now, when you're doing confidence intervals, we did NP hat Q hat. Okay. Um, Here, for hypothesis testing, we could do NP hat Q hat. We can't actually do NPQ because we don't know P, right? We've talked about that already. But for hypothesis testing, we'll do P0Q0. Okay. So in this case, my N was 140. My P0 is the number from my null hypothesis, which in this case is 1/6. What would Q0 be if my P0 is 1/6? What's my Q0? 5/6. Yep, Kelly's got it. All right, so I'm gonna put that in my calculator, see what I get. 140 times 1/6 times 5/6. Oop, oop. You have to hit the right arrow key to do that. I get 19.4. All right. Is that bigger than 10? Yes, it is. So we got yes. Um, so my sample size was big enough. Did anybody get no on this one? Just curious. Okay. Now, I will pause here for a second because, oh, Yvette got a no. So yeah. Um, I'm curious what your sample size was. Mine was 140. If you had somewhere in the 70s, oh, could I do that again? Sure. Um, so take your sample size, your N, times 1/6 times 5/6. So Yvette had a sample size of 41. So it would be 41 is my N times 1/6. And then I need to hit my right arrow and then do times 5/6. And so her N times P times Q was 5, which is not bigger than 10. So she got a null. She got a no for normal, which is fine for the project. We're just going to keep going. Don't worry about whether you got three S's or not. Okay. If you got a no for normal, it just means your sample size wasn't big enough, which means your hypothesis might not be your hypothesis test results might not be accurate. Okay. Um, so for this class, that's not a big deal. When you are, doing real hypothesis testing and you're testing, an actual vaccine or something, yeah, you've got to make sure your sample size is big enough. You can't have a no here, okay? Your results won't be valid. So, okay, uh, so I'm gonna pause here for a second because especially when you're dealing with probability, there's p values and p things flying all over the place. Okay, so we have p, which is the population proportion, and we don't know p. You can never know p. Okay, so that's why we do p hat, which is the sample proportion, and that's x divided by n, and it's close to your p-value. We don't know what p is, okay, but you hope that p hat is close. Now, we also have p0, which is a number. P0 is the number you are comparing against in your null hypothesis. In my case, my P0 was 1/6. I don't know what P is. I'm hoping it's 1/6. My P hat was this. My P0 is, something else. Okay. And then on top of that, there's the P value, which we're going to get when we get to step 4 down here for the hypothesis test. And that P value is the corresponding probability that goes with the Z value you're going to find, right? So um, your P value is what you're going to compare against your alpha, okay? If your P value is very small, then that means we reject the null hypothesis, right? If your P value is very large, we do not reject, right? So, so we're using P for a lot of different things, and I apologize for that, right? I've said before that like if you just use the alphabet A, B, C, D, you in math you run out of there's there's only 26 letters, so you run out of those. So then you start using the Greek letters, and you run out of those. So then you start using capital Greek letters and lowercase, and so anyway, so try to keep all these straight because and I admit it's complicated. There's a lot going on. Um, if you had used P hat and Q hat here, it's not going to make a huge difference. Okay. My my NPQ, I got 19.4. If instead I had done, doing P0, if I'd done P hat, mine was 0.2 and my Q hat is 0.8, I would have gotten 22.4. 19.4 versus 22.4, they're both bigger than 10. They're not off by much. It's not a huge difference. Okay. If Yvette if had used if she had used 41 times 0.2 times 0. If she had used p hat, she would have gotten 6.5 instead of 5.6. Neither of those is bigger than 10. She still would have gotten a no. It's not a huge difference. Okay. Um, but technically for hypothesis testing, you use P0 instead of P hat. Whatever. Um, okay. So question number 5. Regardless of whether you got 3 S's, so even if you got a no here, that's okay. Let's keep going. Let's do the hypothesis testing and see what happens. Okay. Test your hypothesis from number 3 using your level of significance from number 1. So I said we're going to use this one for M&M, so I'm using 0.93. Okay. All right, so there's 6 steps, right? So the first step, we've already done the first step, but I'll do it again. So list out my hypotheses. P is 1/6, and my alternative hypothesis, you can write a 1 or an A, I don't care, and greater than 1/6. Okay. Step 2, what is our alpha? And my alpha was 0.093. Just write down whatever random number you got from that StatCrunch, okay? Step 3, we're going to calculate our Z value, okay? Um, and this Z value is what it's these, I'm calling it Z0 because I'm going to test it. I'm testing the null hypothesis. I'm going to take this, I'm going to calculate a p-value and compare that to my alpha, okay? So with confidence intervals, we wrote Z alpha over 2. That was just to remind us that the alpha's been split in half because confidence interval is always between. Here, sometimes I'll do a left tail test or right tail test. Okay. Where did I get the 0.93? That is coming from right here. So when I did my StatCrunch, I did data, sample, and I got 2 random numbers. Here's the 2 random numbers that I got. Mine was 0.93. Yours will be different. Okay. So you're just going to pick 2 random numbers from here. You're going to have StatCrunch pick 2 random numbers from this list. Okay, so you'll write it right here, and then you'll write your alpha. Okay, your alpha will be different from mine. All right, so where do we find this formula for calculating my z for hypothesis testing? This is going to be on page 262. Okay, 262. Page 262. Page 262 is hypothesis testing for a single proportion. We're doing proportions. What percent of M&Ms are orange? Means is on page 263. Okay. So you can see right here, when we're testing normal, we do NP0Q0 is bigger than 10 as opposed to NP hat Q hat. Okay. Not a huge difference. As I showed you a second ago, you're still going to get a yes or no if you'd use P hat. But step 3, this is our formula. Okay. This is how we're going to calculate our Z value. And that Z value has a corresponding probability. Every Z has a corresponding probability with it, and every probability has a corresponding Z, and you'll need to be able to switch between those two using the normal calculator in StatCrunch, right? That's what we talked about in chapter 7. So let's write out our formula. It is P hat minus P0 big square root P0 Q0 over N. Got fractions inside of fractions and square roots. It's crazy, right? There's P's everywhere, right? I'll admit, it can be difficult to keep track of which P means which thing, okay? So if you need to write out what they are, that's okay. All right, so now we're going to substitute in our numbers. So my P hat was 0.200. P0, what's P0? I'll ask you guys. P0 is 1/6. Now, I'm not going to write it as 1/6 because then I have fractions inside of additional fractions and just melt my brain. I'm going to write it as a decimal, 0.167. Okay. 1/6. 1 divided by 6 is 1 divided by 6 is 0.166. Okay, so that's how I'm going to write it. All right. Hopefully everybody's okay with that. Square root my P0, we said that a second ago, 167. My Q0 then is going to be 560.833. 0.833. Okay. And my N was 140. Yeah, that's was 41. Yours will be something else. Okay. So we need to calculate what that is. Now, when you put this in the calculator, you need parentheses around the top. There are invisible parentheses around the top and bottom of every fraction. You know they're there. The calculator does not. Okay, so it's going to be parenthesis 0.2 minus 0.167, close my parenthesis, divide by SQRT, 0.167, 0.833, divided by 140. And I get a z value of 1.04 7. I'm going to do 4 decimal places here. 469. Now that's my Z value. Yours is going to be different, which is fine. Okay. All right. Step 4, I need to figure out for this Z, what's the corresponding p-value, right? The normal curve looks like this, right? And my Z value is right here, 1.04, or I'm just going to write it as Z0, except I've lost my eraser. There it is. Okay. So Z0 is right there. So this shaded area right here is my p-value. I need to figure out how much that is. Okay. With confidence intervals, you remember confidence intervals we shaded in the middle, and then we had the two white spaces on the outside. And that was because those were my alpha, and I cared about my confidence level. I cared about what was in the middle. Hypothesis testing is slightly different. Hypothesis testing, we're going to shade to the right or to the left, or maybe both. If we're doing a two-tail test, we're going to leave the middle empty. And that's because we're comparing this p-value to alpha, and alpha is the tails. Okay, your confidence level is the middle, your alpha is the tail sides, right? So, okay, to do this, to find my p-value, I need to compare it, or I need to get to StatCrunch. I need to do the normal calculator, okay? So I'm gonna come over here to calculator and I'm gonna do stat, calculators, normal, and I want greater than, because I'm testing this side, right? And I don't know my p-value. I'm trying to find it. I'm going to put in my z-value here, 6.9, compute. My p-value is 0.1476. Okay. So write that right here. So I'll do that again for you. I did stat, calculators, normal, and then I'm going to switch this to greater. I'm doing greater because I'm shading on this side, okay? And I'm going to put in my Z value that I computed a second ago, 1.0469, and that gives me my P value, 0.1475, okay? And that's my P value here. So make sure you put your Z value here. Don't put it over here. This is the probability. This is the P value you're trying to get. Okay. So don't put that there, or you'll get an error. Okay. Kelly said she's getting 0. So Kelly, what'd you get for your Z value? You got a Z value of 29? That's crazy. Yeah, you're gonna get 0 for that. So a Z value is how many standard deviations you are away from the mean. So you can see on this x-axis here, I see the numbers 0, 1, 2, 3. I see -1, -2, -3. Uh, 4, 5, 6, 7, 8, 9, 10. This curve actually technically keeps going forever. But 29 is like way over here. That's so far out there that there's no way you can round that you don't get 0. Okay. So I would double check your Z value calculation, because 29 is a monstrous Z. This would be like if my entire bag was all orange. Now, if you're still confused, there's two ways that you can do this hypothesis testing. The way I'm doing it right now is using the calculator. I used the calculator for Desmos to get this. I used the normal calculator, stat calculators normal, to get my p-value. And now I'm going to finish the problem. I'll show you how to do it a different way using StatCrunch, okay? And instead of using the calculators, and either way is fine, okay? So we'll come back to this in a second, okay? I'm gonna finish this problem and then I'll show you that other way to do it, okay? So step 5 is I need to compare my p-value to my alpha, okay? My p-value was 0.1476 and my alpha was 0.093. My p-value is bigger than my alpha, which means I do not reject the null hypothesis. Okay. If the p-value is less than alpha, we reject the null hypothesis. Okay. So you're either going to reject the null or do not reject the null. You're either going to accept or do not accept the alternative hypothesis. Okay. So I'm curious, did anybody reject the null or not? Yeah, that's much more normal, Kelly. That sounds much better. So Yvette did reject the null hypothesis. Interesting. Okay. And then lastly, we write out our conclusion. So my conclusion, you're going to write either there is sufficient evidence, or you're going to write there is not sufficient evidence. If you do not reject the null, then there is not sufficient evidence. If you reject the null, then there is sufficient evidence. It's either way, you're writing out pretty much the same thing. There is not sufficient evidence to support Willy Wonka's claim. Okay. To support, what was his claim again? To support the claim that more than 1/6 of all M&Ms are orange. He was claiming that they were using way more orange than any other color, and I showed that there is not sufficient evidence to support that claim. Okay. Yep. I'll go over the rest. I'll go back over this again with you guys. Okay. So, um, there is not sufficient evidence to support the claim that more than 1/6 of all M&Ms are orange. Okay. Now, I do want to point out that my my results in my sample, I had the most orange. Okay. I had more orange than any of the other colors. But even though I had more orange than any other color, I can't just say, oh, well, that's going to happen every time, right? I can't say that every sample, every bag is going to have more orange than any other color. Okay. In order to make that claim, in order to validate Willy Wonka's claim, um, I need to have so many more oranges that uh, there's no way that the result was just because of randomness. Okay. So I have the most orange. Rachel happened to have the most orange as well. Maybe some of you guys had a different color that was more. Okay. So if on the other hand, um, I had a very large alpha and my p-value was tiny, like Kelly a second ago said that she had a z-value of 29 and that gave her a p-value of 0. In that case, that would be like the case of like her bag had every single M&M was orange except maybe like two or three. If that happens, that's not a random result. Something weird happened, right? You open up that bag and it's all oranges except like one or two. You gotta say like, what's going on here? right? That's what hypothesis testing is doing, is it's saying, is this result so strange that there's no way it happened because of randomness? Okay. Kelly did have 50 oranges. Oh yeah, maybe that's what happened, right? If there is something weird like that, you have to ask yourself, do I really want to eat this bag? What's going on with this? All right, so I said there's two ways we could have done this. We didn't have to use the calculators. Instead, let's pretend that we were back on step 3. And I've written out my formula, I've substituted it. At this point, the other way that I could have done this to get my z-value and my p-value is I could have used the StatCrunch hypothesis testing. So let's take a look at what that looks like. Back over in StatCrunch, just a blank one, okay? So it doesn't matter that I've got stuff in here. I'm going to do stat and then z-stats, one sample with summary, okay? Oh, that's for means. I got myself turned around now. Proportion stats. That's for means. Proportion stats. There we go. Stat, proportion stats, one sample with summary. It's at the top of page 262, right here. Stat, proportions. I'm trying to go off of memory and I failed. All right. Sometimes we deal with means and sometimes we deal with proportions, right? And it's important to pay attention to which one you're working on. Right now, I'm working on proportions, so I should have done stat proportion stats. One sample with summary. Stat proportion stats, one sample with summary. Okay. And we put in the number of successes. That was our X. I had 28 oranges. Observations, I had 140 total M&Ms. And for confidence intervals, we clicked this button. Don't do that. We want to keep the blue dot on hypothesis testing. And we want to compare that to P is 0.167. And here we choose whether we're doing not equal, less than. I am doing greater than 1/6, correct? That's what our alternative hypothesis was. P is greater than 1/6, okay? And then don't click on that dot or anything, but do click this button right here. Actually, no, I don't think you do. Yeah, don't click that button. That's just going to confuse me if I do that. Yeah, let's leave that unclicked. Yeah, because they give you the z set. If I had clicked that, it's going to give me two different z values. Yeah, now I'm getting two different z values. Don't do that. All right, so put in your x, put in your n, put in your p0 greater than, but don't click this button. We did click this button for confidence intervals because we needed that z value or that t value. Yeah, I'll explain that in a second. Just leave that unclicked. Hit compute. Um, and here is our results, okay, for this hypothesis testing. So our p hat was 0.2. Our z stat is 1.04688, which is the same number that I got when I typed that into Desmos. Okay, so I didn't have to do all of this stuff in the calculators. Could have just put it in StatCrunch and gotten this. And then the p-value that it gave me is 0.1476. That's right here. I got that from the normal calculator, so you can do that in StatCrunch as well. And then you compare that p-value to your alpha, okay? So either way is fine. If you prefer typing in Desmos or you prefer typing it in StatCrunch, either way is fine, and you get very similar results. You might be off by a little bit just due to rounding, and either of those answers is fine. Okay. Okay. Um, My result was that there is not enough evidence to claim that more than one-sixth of all M&Ms are orange. And that's because I did have more orange than others, any of the other colors, but not like a crazy amount. Okay, if you had a crazy amount, well then maybe you uh, did reject the null and you say there is sufficient evidence to support the claim that more than one-sixth of all M&Ms are orange. Okay. Um, but we know that's not actually the case, okay? Usually we don't know P, okay? In this case, we kind of do. The M&M company, they make the same amount of every color, okay? So in this case, we know that P is one-sixth. We know that the null hypothesis is true, okay? You can never really know the hypothesis, the null hypothesis is true, but in this case, we do, okay? We're kind of cheating here, okay? But the reason I bring that up is this last question, number 6 on this page, is saying, what's the probability of making a type 1 error in the setup for the hypothesis test above? The uh, the probability of making a type 1 error is your alpha. My alpha was 0.093, so you just put that right here. Whatever your alpha was, whatever number you got from the random significant levels for number 1, that's what you're putting here for number 6. I have a 9% chance of making a type 1 error. Now, in this case, I didn't, but some of you guys said you rejected the null hypothesis. You said, oh, yeah, there's way more oranges than any other color, okay, or whatever color yours was, okay. Well, that's not true. What's happening is you made an error, you made a type 1 error. It's not like a problem, okay? Um, but there's a 9% chance that that happens, okay? Or maybe yours was a 5% or whatever it was, okay? Your hypothesis test isn't perfect because you didn't sample every single candy. We can't do that, right? We can never be 100% sure. So there's always some chance of making an error, okay? And in this case, it's not a big deal. We're talking about M&Ms. Who really cares what color they are? They all taste the same, okay? But for other things, like if you were testing how safe your cars are and you want to show that your cars are safer than any other cars out there, um, then you know there's a chance that well you might make a mistake, okay, and that actually you know maybe your cars are less safe, okay, and that's a problem, okay. All right. That's it for this one. We're going to move on to Skittles on page 576. And a lot of these steps will be very similar, okay? We're This might have felt like, oh my God, I don't know what we just did. Okay. We're The Skittles one is basically exact same steps. And after you do these like a bunch of different times, it's gonna feel like, okay, we've done this 100 times. It's just easy. It's just something I'm used to at this point. Especially when we get to the chapter 10 review, we're gonna do this over and over and over. Okay? All right.
Hear you. Could anybody else hear that?
Oh, can you hear me okay?
I can now, but I couldn't for, I don't know,
Oh no.
something.
I'm sorry. Yeah, my internet must have taken a hiccup, so it keeps cutting in and out. Okay. Oh, I turned off my video. Hopefully that saves me a little bit on bandwidth. Do let me know if I cut out again and I can repeat whatever I said, okay?
Yeah.
All I was saying is if you're not feeling comfortable with hypothesis testing yet, that's totally fine. We're gonna do another one and hopefully it's repetition will make it easier. All right, can you at least see my screen? Page 576.
Yes.
You see my screen?
That looks good.
Yes? Okay.
I can hear you now too.
All right. For now, yeah. All right, which Skittles color had the lowest count in your sample? There's a tie, just pick one. Lowest count. Let me go look at my data. Um, my lowest, I had orange and purple. They were both the lowest at 42, and I just have to pick one. I'll do purple. It would be interesting if I had done orange because I had the most orange M&Ms and then the least orange Skittles. So I did orange for both on this project, but I'll do purple. That's fine. I like the purple ones a little bit better. All right. How many did I have? I had 42. Orange again. Kelly's all orange. That's totally fine. No big deal if you get the same. My total is 238. And I need to know what p hat is. So x divided by n. Mine is 0.176. All right. And that looks fine. If your p-value is close to 20%, choose the second color. Yeah, we don't need to do that. This is far off enough. Sure. Willy Wonka is back. He's bothering you again. Ugh. Claims that the proportion of Skittles that are your color from number 7 is different from 20%. Write the appropriate hypotheses hypotheses to test Willy's claim. So our null hypothesis here is that P equals, it's always equals for the null hypothesis, P equals 20%. 1 divided by 5, 1/5 is 20%. So 0.20. Okay. For the alternative hypothesis, okay, it's P, and then should we be using less than, greater than, or not equal? Well, that depends on whether he is saying more than, less than, or just different, okay? So yeah, you guys got it, not equal here. So he doesn't know whether it's greater or less. He's just saying they're not the same. So he's saying that they might be making more purple, less purple, but the key is they're not doing them in equal proportions. Okay. So it does matter a little bit because it's going to change your p-value. It's going to make your p-value twice as big as it would be in a one-tailed test. And the reason that that matters is it'll make it slightly harder to reject the null. Okay, so one-tailed test and two-tailed tests are not exactly the same. So pay attention to that. Okay, there's our hypotheses. Next, verify that all the requirements to conduct an appropriate test of the hypotheses are met. We have to make sure that we are meeting the conditions of the central limit theorem. Right? The central limit theorem is what allows us to do this hypothesis testing. So it's running in the background, but it's what allows us to, use the normal curve because it's the central limit theorem from chapter 8 says that, as long as you meet these three conditions, then the sampling distribution of proportions is normal. Okay. All right. So random, same thing, right? Yes. Every candy, every Skittle had equal chance of being selected, right? Had equal chance of being in your sample, right? Nobody went out and picked and choose like their candies. They just chose a random bag, okay? Independent. You need to check this. My N is 238. 20 times 238. I need to calculate. 4760. Less than all Skittles. Yep, for sure, right? There's trillions of Skittles, right? Yes, of course. For sure. All right. For this one, we'll do NP0Q0. For hypothesis testing, we'll compare NP0Q0. Now, part of the reason why we use P0 and Q0 here is when you're doing hypothesis testing, think about the order that we would do this is not the way that we've been doing it. You would start with deciding what your alpha is going to be. We chose a random alpha. I've already mentioned that you don't do that. You have a discussion with whoever you're providing these results to and talk about what alpha should be. After you've done that, you set up your hypotheses and then you check these numbers here. Okay. Normally, you don't have what p hat and q hat are yet. You get p hat and q hat after you take the sample. Okay. Now, you do have the sample size. Okay. But you haven't actually done the test. You're supposed to check these requirements before you do the test. You can't go and say, all right, let's see how effective our vaccine is. Go inject a bunch of random people with that vaccine and then talk about did we meet the central limit theorem? That's ridiculous. You can't do that. Okay. So you don't actually have p hat until after you've done the sample. You do have the null hypothesis. You do have this. So that's why we use P0 and Q0 when we're checking. Now, I mentioned earlier, if you put P hat and Q hat here, it's not going to be a huge difference. You're still going to get yes or no, okay? But that's why it switches, okay? With confidence intervals, there isn't a P0 or Q0 to compare to. With confidence intervals, we had to use P hat because we don't know P. There's no P0. P hat was all we had, okay? So anyway, 238 is my N. Your P0 is 20%. What's Q0 then? 80%. Yep, you got it. And we'll put that in the calculator. 238 times 0.2 times 0.8. And I got 38. And that is bigger than 10. So mine is a yes. Did anybody get a no? I'm always curious about that. What would you need for a no? 0.2 times 0.8. And then if I do 10 divided by that, no, 10 divided by 62. Anybody that had a sample size of 62 or less would have gotten a no. 63 or more would have gotten a yes. So, everybody get a no for this one? No? Everybody got a yes? Nice. Okay. Sounds good. Um, so we got 18. So, yep, you're good, Stella. You got a yes. That means that your hypothesis testing results will be reliable. Now, as we've said before, you can never be 100%, right? But you can at least be, within alpha. You can be like, okay, we're 90% confident, 93%. Okay. Our last page is page 577, and we're going to, regardless of whether you got yeses or nos, regardless of whether the requirements were met, test your hypothesis using the level of significance from number 2. So this was my alpha for M&Ms. This will be my alpha for Skittles. Okay, so we're going to switch it up. Step 1, we'll just list out our hypotheses again. Oops, this is supposed to be P equals, not hypotheses equals, P equals 20%. And our null hypothesis, our alternative hypothesis, not equal 20. Could be more, could be less, I don't know. Okay. My alpha for this one is 0.071. Okay. That's the probability of making a type 1 error. So just because, just because I've got 238 Skittles doesn't mean that those randomly might not still be like, different than other bags. So step 3. So I'll say again, so this is whatever alpha you had for Skittles. Okay. So it's a random number that came from the levels of significance. Okay. So when I did so I got this for M&Ms and I got this for Skittles. Okay. All right. Our formula on page 262 was P hat minus P0 over P0 Q0 square rooted N. And we'll substitute in our numbers. My P hat for purple was 0.176. P0 is 20%. Q0 is 80%. Oops, I need that to be a 0 point. That. 0.80. I don't mind if you write 0.20. You don't have to write the 0 out in front. But I put the 0 in there just so that, if you can't see the dot, like if I write my dot too small, that it doesn't get confusing. Like, oh, is it the number 20? My N was 238. Now, this time I'm not going to do the calculator. So I said there's 2 ways you can do it. One way is you can put this into the Desmos calculator, and then you can use the stat calculator's normal to get your Z. This time I am going to do it just using StatCrunch. Okay. So at the top of page 262, it says you do stat, proportion stats, one sample with summary. Stat, proportion stats, one sample with summary. Okay. And then I had 42 purples. I had a total of 238 Skittles altogether. I'm comparing that to 0.20, and I'm doing a two-tailed test, which means I'm doing not equal. Okay. Not going to click this button. We'll show you why that is in a second, but anyway, let's do compute. And here's our results. So my Z stat is negative 0.9075. We'll probably get away with 3 decimal places on that. I probably don't need 4. And then my p-value, I'll need that for step 4. Okay. So step 4, I'm going to draw my picture. Now, there is a button that you can click down here that'll show you the plot. I don't know if you need that or not. So it just shows you the shading, but you shade, if it's a not equal, you shade both sides. So anyway, so step 4, so I've written out my Z value that I got from StatCrunch. Step 4, I'm doing my shading, okay? And I've got Z0 and negative Z0, and I'm shading both sides because it's a two-tailed test. Okay? Which means these two together add up to my p-value. Which in this case, what was my p-value? My p-value was 0.3642. 3642. That is a huge p-value. There's no way we're rejecting. Because we're going to compare these. So step 5, I'm comparing 0.3642. I'm comparing that to my alpha. My alpha was 0.071, and I got that from StatCrunch earlier, right? That was just my random number that they gave me from, from StatCrunch. Okay. So I get greater than. So I do not reject. Okay. And then we'll write out our conclusion. So if you did reject, you would write there is sufficient evidence. I am going to write there is not sufficient evidence. To support Willie's claim. To support the claim, what was his claim? That portion of purple Skittles is not 20%. Okay. There's not sufficient evidence to the claim. There's not sufficient evidence to support the claim. Ah, it's terrible. Sorry, everybody. There's not sufficient evidence to support the claim. The proportion of purple Skittles is not 20%. Okay. Okay, so I mentioned not to click this button. We do want to click this show critical value when we were doing hypothesis or sorry, confidence intervals. Um, but I don't want to do it here because if you do, it's going to give you two z values and that's confusing. Um, the z value that I want is this one, negative 0.907, right? That's the number that I wrote right here. Okay. But it also gives me this critical z value. Um, what is that? That's the z value for this p-value. What the hell does that mean? We are comparing p-value and the alpha to decide whether to reject the null hypothesis or not. You don't have to compare p-values. You can compare z-values. Every probability has a corresponding z that goes with it, and alpha is a probability. So earlier when I was listing out all the probabilities, right? There's p and there's p hat and there's p0. There's alpha too. That is also a probability. It is the probability of making a type 1 error. Okay. And it has a corresponding z value, which you could compare to this z instead. We're not going to do it that way. I'm not even going to show you that. We're going to stick with just comparing p-values because I don't want to confuse you. Okay. So anyway, that's why we're not clicking that button. Now, I mentioned that it is important to pay attention to whether you are doing a one-tail test or a two-tail test. So if I had not done it as a two-tail test, if I hadn't done it as not equal, if I had done it as less than, and then done this computation, I still get the same z, okay? But my p value changed. How is that possible? Every z value, every z has a corresponding probability. So why is that number different? And it's because if I'm doing a one-tail test, I'm only looking at this side over here, okay? These two shaded areas add up to, for me, 0.3642, okay? If I only had one of them, then this will be half as big. Half as big would be 0.1821, okay? And that's the p-value that I'm getting if I do a less than. So it's important to pay attention to whether you have a one-tail test or a two-tail test because it's going to change your p-value. And it's also important to note that this hypothesis should be set up before you do your sample. We mentioned that earlier, okay? That means that you can't change midway through and say, oh, I don't want a not equal, I don't want a two-tailed test anymore. I'm changing my mind and doing a one-tailed test because that will change your result possibly, okay? In practice, most of the time you want to reject the null hypothesis, okay? The researchers want to reject the null hypothesis. They want their vaccine to be effective. They want it to be more effective than a placebo. They want their cars to be safer. They want their commercial to be more effective. Okay. But just because you want that doesn't mean you can fudge your results later on so that you can reject the null. Okay. So just because a one-tail test is easier to reject the null on doesn't mean you get to change your mind later. Okay. Anyway, last question on the page. Question number 11. Which test had a higher chance of a type 1 error in the setup? Okay. So to answer that, you're going to compare your alphas that you had. So I had an alpha for M&Ms of 0.93. For Skittles, I had 0.71. Which of these is bigger? For me, a 9% type 1 error is bigger than a 7%. So mine was M&Ms. Now, if your Skittle alpha was bigger, then you would circle Skittles. Okay. Question number 12, which test had a higher chance of a type 1 error in the setup, is the same question as number 11. That's a typo. This used to say type 2, and I complained to Alana and said, no, you can't do type 2. So she must have changed it back to type 1, but that's the same question. So yeah, just circle whichever one you want for number 12. Which test had a higher chance of type 1? That is your alphas. Okay. Which test had a higher chance of a type 2 error? We don't know. There is a probability for the chance of making a type 2 error. It's not alpha, it's beta. We haven't talked about beta, and we're not going to really calculate beta in this class. We might mention it. Beta is the power of your test, okay? It's the probability of making a type 2 error. And it is related to alpha. A large alpha means a small beta. Small beta means a large alpha, okay? So you could say, oh, well, if I circled M&Ms here, I should circle Skittles here. That's not necessarily true. That is true if the sample sizes are the same. My sample sizes were not the same. I had a sample size of 140 M&Ms, but only, but way more. I had 238. I had like way more Skittles, which means you'll remember that a larger sample size means your results are more accurate. Okay. It is possible that you have a high chance of a type 1 error and also have a high chance of a type 2 error if your sample size is not big enough. Okay. Now, if the sample sizes were the same, yeah, circle this one, then circle this one, you're done. Okay. Um, but number 12 is we're not even, yeah, you don't need an answer. It's fine. Um, we might mention that a little more. I might actually pull up the picture um, for beta next time. But for now, that is it for today. Make sure you submit this for the project. Make sure you fill out what you want to do on the morning of April 16th, that survey I sent. And if you have questions, stick around. Otherwise, I will talk to you on Thursday.
Thank you.
Yeah, thank you. Lane, I really haven't kept track of these typos like I should.
I know. I see that too, and I think
Like,
should
I
be.
find them, I talk about them in class, and then I kind of just move on, and then later I'm like,
I
oh
know.
crap.
I need to be making a list of those, and I forget every time because I would have to send like all these emails to Alana. But
Yeah, I mean, it's supposed to be just one thing at the end of the semester because she's gonna make
yeah.
changes to it. But anyway,
So let me try to to help and keep track of these things.
eh, so all right. Well, thanks, Lane. I'll talk to
Sorry.
you later.
Thanks, Joe. Have a good day.
You too. Bye.
Bye.